On this video, I'd like to talk with you a little bit about finding zeros of a function. In particular, we're going to look at quadratic functions. And I think you have a few problems like this on assignment 6. So let's say you have a quadratic function that looks like this, and you're asked to find the zeros of the function. First of all, let's make sure we know what a zero of a function is. A zero is a number you'd plug in to the function, and then the output would be 0. So for example, is 1 a 0? Well, let's see. If I'm going to take 1 and plug it in, 6 times 1 is 6, plus 1 makes 7. Take away 15 is negative 8. So the answer was not 0. Therefore, 1 is not a 0 of this function. And one way you could go about it is you could keep trying to plug in numbers again and again and again, and eventually you try to come up with the zeros. That's not a very efficient method. So we're going to look at 3 methods. Okay. So the first method is a graphing method. If we were able to make a graph of this function, and as you know, it is a parabola, so we could put this equation into Desmos, or I'm going to put it into my graphing calculator. So here I've typed in 6x squared plus x minus 15. And I'm going to hit graph, and I had to play around with the window a little bit to get a nice scale. But then if I use the trace feature on the calculator, I can basically, I think, just sort of move the cursor along the graph until I get kind of close to 0. So let's see, I'm pretty close, about 1.57. Let's see if I go back, that's about 1.45. So maybe about 1.5 might be a 0. So I would say approximately 1.5 could be a 0 of the function. And then if I were to slide to the left, let's see what I get for an estimate here. So about negative 1.7. Negative 1.6, so I don't know, maybe about 1.65. Negative 1.65. And this is kind of the drawback with the graphing method is you can only be like approximate here. It's very tough to get exact value when you use the graphing approach. Depending upon what you use for graphing, Desmos sometimes can be very precise. Perhaps a bit more so than your calculator. So that's one technique, the graphing technique. Let's look at 2 others that we often use. One is the factoring technique. And so what would that involve? Well, you'd set the equation equal to 0. So 6x squared plus x minus 15 equals 0. And then you try to break this down into 2 factors. Now, many of you have learned different ways to factor things. I'll show you the method that I like to use and what I was taught. The product of these first 2, okay, has to make 6x squared. So it could be 3x and 2x. But it could also be 6x and 1x. You're never quite sure. There's a little bit of guessing and checking in this process. I'm going to go ahead and try 3x and 2x. And if I fail with this, I'll then go back and consider the 6x and the 1x. Okay, so then you look at the last term, which is 15. And I know that this times this, the product of the last terms has to be 15. Well, that's either 3 and 5 or 15 and 1. And again, it's no way of knowing for certain. I'll just throw in a 3 and a 5, and then I'll test it. And here's how you test it. You say, well, the outside product is 15x. The inside product is 6x. 15x and 6x. I don't think 15x and 6x can combine to make 1x. So this arrangement doesn't look very good. So let me go ahead and try to flip-flop the 3 and the 5 around and see if that looks any better. So that gives me 9x and 10x. Okay, now that's got potential. If I had 10x minus 9x, 10x minus 9x, that would get me 1x in the middle. So I'm feeling like I'm close. So if I wanted to keep the 10x as positive and then have my 9x be negative, and let's see how that works. 3x times 2x, 6x squared. Negative 9x, positive 10x, that's 1x. And 5 times negative 3 is negative 15. So I have found the factorization through a little bit of trial and error. Again, if you like to use sort of the box method or the diamond method, whatever you use that you're comfortable with for factoring is up to you. Once you have the factors, you then split them up into what we call cases. Well, now 3x plus 5 equals 0, or 2x minus 3 equals 0. We're using an idea that says, okay, well, if something times something makes 0, then one factor or the other has to be 0. Okay? This is often called the zero product property. And the zero product property, in essence, says, well, if I'm multiplying two things together and the product is 0, then one of the two factors I started with has to be 0 also. So this is what's called the zero product property. And I always like students to show the cases. And so now you solve each case. So you take away 5, you have 3x equals negative 5. Divide by 3, you have x equals negative 5 1/3. Now that's pretty good because that's negative 1.66, 1.67, and that kind of goes with what my graph suggested up here. And then we'll try the other case. I'll move the 3 over, so 2x equals 3. I'll divide by 2, and I get 3 halves. And I also like that answer. That's 1.5, and that goes along with what the graph suggested here. So now you get the advantage of actually having precision from using an algebraic technique. So this is the factoring idea, taking the quadratic and factoring it out and then solving each case. Now you got to be careful. Whereas graphing is not always the most precise, it can be pretty quick because you're using a calculator or say Desmos. Factoring can be very precise, but it doesn't always work. There are certain trinomials that are prime that cannot be factored out. And so there are going to be times where just factoring, you won't get anywhere with factoring. So we look at a third method on here, which is called completing the square. Completing the square. And this is a great method because it'll be very precise and it always works. You can always complete the square when you have a quadratic. So let's look at how to complete the square. So we start with our original expression, 6x squared plus x minus 15 equals 0. Okay, now what I'm going to do is I'm going to move the 15 over. I like to get the kind of the quadratic term and the linear term together, and I send the constant over to the other side. Okay, then the next step is I need to have this thing be a perfect square, and 6x squared is not a perfect square, so I'm going to go ahead and divide everything by 6. And this is going to get a little messy. X squared plus 1/6 x equals, let's see, 15/6. That reduces to I think 5 over 2. So everything's been divided by 6. So part of the issue is you have to be able to work with fractions here a little bit. Okay, so now comes the completing the square part. I want this thing, whatever it is, to factor perfectly. And by that I mean I want it to be x and x for x squared, and I need the outside and inside to add up to 1/6 x. So I need these two things to be identical and add up to 1/6. So I really need half of 1/6. I need 1/12 right here and here. And if you think about this, 1/12 x plus 1/12 x makes 2/12 x, and that makes 1/6 x. So this is really what I'm hoping I can do, is I want to create a perfect binomial square. But how do I force that to happen? Well, I think about 1/12 times 1/12, that's 1 over 144, and I'm going to add that right here. I'm going to add 1 over 144 here. That's going to force the factoring to work. But of course, if I add 1 over 144 here, I have to add it over here as well. I've got to keep the equation balanced. I can't just change one side of the equation without making a similar change on the other side. So what does that do? Well, I now have two fractions, so I have to get a common denominator and add these together. So if I multiply, I think, let's see, 2 goes into 144. I think that's 72 times. So if I multiply the bottom by 72 and the top by 72, I'll have a common denominator. So this is 350 and 10. That's 360, I think. 360. Let's see, 5 to 350 and 10. Yeah, I think that's 360 over 144. Plus the 1 over 144 equals 361 over 144. So now I take the square root of both sides. And so this is going to leave me with x plus 1/12. And then over here, I'm kind of hoping that's a perfect square. It isn't always, but let's see if we can make something like that happen here. So let's see if I can square it. Second root 361. Yes, it's a perfect square. It's 19. So okay, so I'm in business here. So I know that this is plus or minus 19 over 12. That would be the root of 144. And now I'll minus the 1/12. X equals negative 1/12 plus or minus 19 over 12. And so let's see where that leads. If I had negative 1 plus 19, that's 18 over 12. The other option is negative 1 minus 19 is negative 20 over 12. In reducing those, let's see, if I divide a 6 out, that would be 3 over 2, or the other option, let's see, I guess I could divide a 4 out, would be negative 5 over 3. And so I get the answers that I had up here from factoring. So completing the square can take a little longer, takes a little more writing than the factoring. It's not quite as fast as factoring, but it will always work. This process will always take you to a solution. Now, of course, there's a fourth way to do this, which is, I think everyone's pretty familiar with it, the quadratic formula. And as you probably already know, the quadratic formula is really what comes about from the completing the square process. And so the formula, just to remind you, x equals negative b plus or minus square root of b squared minus 4ac all over 2a, where a is the quadratic coefficient, b is the linear coefficient, and c is the constant. So if we had plugged in for a our 6, b 1, and c negative 15, and we put those numbers into this formula and did all the math, we would hopefully get to the same answers we have here. And students usually have pretty good experience with this, so I won't put this on the video, plus I've run out of paper. So anyhow, there are 1, 2, 3, 4 ways to find the zeros of a function. And again, on assignment 6, I'll be asking you to show me some of these methods. So thanks for watching.